Hey guys, and welcome back to This Week in STEM. I'm Steph, and before we jump into what happened this week in STEM news, I'd like to wish you all a very happy Pi Day! Pi Day! For any non-math enthusiasts out there, like those exist, let's be serious. Pie is not only a delicious pastry to be consumed every day that it is possibly available and put in front of you to put in your face, pi is also one of math's most famous irrational numbers, most commonly rounded to 3.14. What makes today so special? Well, it is the once-in-a-lifetime Pi Day. Well, unless you're from one of those unfortunate countries that puts, the day before the month and then it's just Saturday for you. So what makes this Pi Day so special? It is the once-in-a-lifetime Pi Day. Today is 3.1415, and then if you want to keep going at 9:26 this morning and 53 seconds, and you can see you just can kind of keep going, but yeah, it's Pi Day! Yay, Pi Day! It also would have been Albert Einstein's 136th birthday. So happy birthday, Albert! We love you! So what's up first this week? Well, it's not a bird and it's not Superman, you guessed it, it's a plane! A solar plane, in fact. On Monday, Solar Impulse 2 began its historic journey to become the first fixed-wing, solar-powered aircraft to completely circumnavigate the globe.
Over the next 5 months, Solar Impulse 2 will complete its 35,000-kilometer, 10-leg journey around the globe, starting and ending in Abu Dhabi.
While this journey has just begun, the Solar Impulse 2 team is wasting no time in breaking records. In fact, on only the second leg of its journey from Muscat, Oman to Ahmedabad, India, it shattered the world record for the longest flight by a solar-powered aircraft. Now, the team hasn't begun the third leg of its journey yet, and while they're waiting, the two founders behind Solar Impulse, Bertrand Piccard, no relation to Jean-Luc, and Andre Borschberg, are taking their team around to the locals and educating them on the benefits of clean energy and clean technologies. Now, Piccard and Borschberg have been working on the Solar Impulse program for a pretty long time. It all started back in 2009 with Solar Impulse 1, which was a much smaller single-person aircraft. While tiny, it was mighty, and it did set its own records by flying across the United States in 2013.
Now, as you can see here, Solar Impulse 2 isn't just larger than its predecessor, but it has a monster wingspan. At 72 meters, its wingspan is larger than that of a Boeing 747, which makes a lot of sense since you need a lot of surface area to house the 17,000 solar cells required to power the aircraft. Now, despite the large wingspan, the aircraft itself only weighs about 2.3 tons with an average speed of 70 kilometers per hour.
Now, Piccard and Borschberg will take turns piloting the aircraft throughout the legs of their journey, and they've got some really hard legs coming up. For example, they're going to have to fly across the Pacific Ocean and the Atlantic Ocean, the Pacific one being definitely the longest one. While flying, the off-duty guy can only take naps for about 20 minutes just in case he has to jump in and relieve the other pilot. And while the wingspan of this monster is huge, the cockpit is teeny tiny to save on weight, so these guys are flying in really cramped spaces for really long times. So we wish them all the best on their historic flights around the world. If you're interested in tracking Solar Impulse's 2 progress, I'll include a link in the description to their website where they're updating daily. You can also follow them on Twitter where they're updating pretty regularly. I'll include some of those Twitter handles here-ish. Sure. Moving on from the aeronautical side of things to the aerospace world, on Thursday night, NASA launched its Magnetospheric Multiscale, or MMS mission, on board an Atlas V rocket. So why is this mission so important, and what exactly is it studying? Well, MMS is the first mission dedicated to studying something called magnetic reconnection.
Magnetic reconnection occurs when two oppositely directed magnetic fields in plasma break apart and then reconnect.
Now, when magnetic reconnection occurs, magnetic field energy is converted into plasma kinetic energy and thermal energy, which leads to a monstrous explosion. And when I say monstrous, we're talking the equivalent of billions with a B of megatons of TNT. These explosions launch particles through space at almost the speed of light. Now, you're probably thinking, how common are these occurrences really in the universe? Now, despite plasma being the fourth state of matter that everybody seems to forget about, the other three being solid, liquid, and gas, plasma is actually the most abundant state of matter in the universe. So the environment for magnetic reconnection to occur exists everywhere. In fact, magnetic reconnection is the prime suspect behind many events that actually occur in our solar system, such as solar flares. Now, if you remember when Discover launched not that long ago, that week I talked a little bit about what kind of impacts that solar flares and stuff like that can have on Earth. You click on this annotation right here and that should take you back to that video if you want to learn more about the impacts that solar flares can have. So what exactly does this mission look like? Well, it consists of 4 identical spacecraft, all of which were successfully deployed on Thursday, so yay! Now, the next several weeks will be spent deploying booms and antennas and just doing overall checkouts to make sure that everything's functioning as it's supposed to on the 4 spacecraft. After that, the 4 spacecraft will form up in their equivalent of a flying V, which will actually be a pyramid formation, and science missions are scheduled to start in early September. Then these 4 spacecraft will spend the next 2 years studying Earth's magnetosphere. Ideally, the data gathered will give us our first 3D view of magnetic reconnection. And now for something completely unrelated that I don't have a good transition for. Scientists have finally unlocked the secret behind nature's mood rings, or chameleons, and their vibrant color changes. Now, chameleons are not exclusively the only creatures in the animal kingdom that change colors. Squids and octopi can also change colors. What sets them apart is how they change their colors. Now, when a squid or an octopus changes colors, they accumulate or disperse pigments within their skin. Now, in contrast, chameleons change the colors of their skin by adjusting the outer layer of their skin that contains special cells called iridophore cells. Now, what makes these iridophore cells special is the fact that they contain tiny nanocrystals in various shapes and sizes and arrangements that help reflect the light. Now, these cells are the secret behind the chameleon's color change. When a chameleon relaxes or excites its skin, the arrangement of the iridophore cells changes, and so does the wavelength of light that's reflected.
According to the study's senior author, Michelle Milinkovic, a professor of genetics and evolution at the University of Geneva in Switzerland, when the skin is in a relaxed state, the nanocrystals in the iridophore cells are very close to each other. Hence, the cells specifically reflect short wavelengths, such as blue.
On the other hand, if the skin gets excited, like if a bro chameleon sees that other bro chameleon that's been hitting on his chick and he's coming over, then the distances between the nanocrystals in the iridophore cells will increase, and longer wavelengths of light will be reflected, showing colors like red and orange and yellow. Now, while blue is the relaxed color for chameleons, it's not always their natural color. Chameleon skins do contain yellow pigments, and for those of you that didn't fail preschool art class, you know that yellow when mixed with blue creates, you guessed it, green. This green color is actually pretty ideal for when they're camouflaging themselves amongst tree leaves or plants. Now, only adult male chameleons change color, and it's for the usual reasons you'd expect: to attract a mate or to go bro up on rival males. Now, are there real-world technological applications for this discovery? Yes, absolutely. In fact, UC Berkeley has just announced their development of a super thin material that, when flexed, can change color. Now, this material is thinner than a human hair, and it has even tinier ridges etched into its surface.
Now, these ridges are smaller than a wavelength of light, so when the material is flexed, it changes the wavelength of light that is reflected back at you, changing the color you see.
Now, the applications for this technology are almost limitless. It could be used to camouflage the exteriors of vehicles. It could be used as part of the next generation of display technologies. It even could be used to give early warnings when structural components are about to fail, say on buildings or bridges or even airplane wings. If a particular component experiences a lot of stress, the material could change colors, showing signs of fatigue. I personally would just want to wear it so I could do a super awesome chameleon cosplay. So that's it, guys, for this week in STEM. It's got to be a quick one because I actually have to go somewhere very shortly. Now, I know some of you are probably thinking that I missed a lot of planetary science stories this week, and if you were one of those people that's very concerned about all the water discoveries that happened this week that were super, super cool, then you should probably check out the new show that I'm doing on Wednesday, Topic Talks. I may or may not be covering it there. So new Topic Talks on Wednesday. Just a quick reminder, there won't be a new TWISTEM video next week. I'll be traveling Thursday to go see my mom for her birthday next weekend. But you will be getting a Q&A video, which I'm probably going to be shooting tomorrow. So if you have any questions for me, if they're personal, professional, STEM related, go ahead and tweet them at me using the hashtag AskSteph, and I will be going through those tonight and tomorrow and then filming something. Figured since I finally passed 100 subs and 1,000 Twitter followers, I'd have a little getting to know me thing since I won't have time to do a TWISTEM next week. But we will be back the following week, so if you have any stories, don't forget to tweet them at me at StephEz43 on Twitter. So that's it, and I guess I will see you guys later. I have to go be a little mermaid at a friend's daughter's birthday party. What? Did you think I was kidding? This is surprisingly probably not the weirdest thing I've ever done. Ariel out, y'all. And you see where I'm going with this. I don't. Where's my phone? Ariel will be there shortly. Steve, if you're watching this, I got your text. I'm not flaking, I'm doing it. So what? I just threw my phone. Sorry, phone. It also would have been Albert Einstein's 136. I just heard it on camera. Ooh. No bark. Don't you start that again. Sorry, so feminine. No bark. Impulse 2 began its I just spit everywhere. I just made it rain with no dollar bills. Y'all. Ugh. Fixed wing, solar powered aircraft is a completely served. Now the team has yet. I'm waving my arms like a chicken. Number 2. Richard. On Thursday night, NASA launched its